So welcome everybody. Welcome to this lecture in the course like advanced topics. Today I would like to talk about purchasing power parity and especially about relative purchasing power parity. Let's refresh our knowledge from the theory. So more or less, like we are testing the following equation. On the right-hand side of the equation, we have the inflation differential. So inflation rate in the domestic economy minus the inflation rate in the foreign economy. And then on the left-hand side, we have the relative change in the exchange rate. So we can either write it in the following way, or like when we want to be more explicit, like here we have the relative change in the exchange rate on the left-hand side, and then the relative change in the domestic price index, which is like the inflation rate in the domestic economy, and then the relative change in the foreign price level, which is like the foreign inflation rate. So in case that relative purchasing power parity holds, then it will be the case that the relative change in the nominal exchange rate is equal to the inflation differential between, let's say, Euroland or the US. Later on, we will look at the example of Italy and Germany, where Italy is a domestic economy and Germany is a foreign economy. The real exchange rate will be constant in case that relative purchasing power parity holds perfectly. So in case that this equation holds and the domestic inflation rate is at the level of 10% while the foreign price level is constant, then the nominal exchange rate will increase by 10%. So like we are looking at one situation where the domestic inflation rate is equal to 10%, foreign inflation rate equal to 0%, so that the inflation differential is like 10%. And hence, like the exchange rate will increase by 10%. So a depreciation of the domestic currency takes place. So in case that relative purchasing power parity holds, it will be the case that countries which have problems with their internal price stability also have problems with their external price stability. So in case that the inflation rate is higher, then it will be the case that the domestic currency will like depreciate. Let's assume that relative purchasing power parity perfectly holds and create one stylized example. Let's assume that in 1973 the inflation rate in Italy was 12%, while in Germany it was equal to 8%. So the inflation differential is equal to 4%. In case that relative purchasing power parity holds perfectly, the exchange rate should also increase by 4%. In the year 1974, the inflation rate in Italy was like 25%, inflation rate in Germany 5%, so the inflation differential is 20%. And in case that purchasing power parity holds perfectly, the exchange rate should increase by 20%. In 1975, inflation differential at 6% and hence 6% increase in the exchange rate. And in 76, like 16% inflation differential, and the exchange rate should increase by 16%. Let's use this stylized data set where purchasing power parity holds and create a scatter diagram. So here we can see our 4 data points, and hence it is the case that we put like the inflation differential on the horizontal axis. We put the relative change of the exchange rate on the vertical axis. This is like data point number 1. This is like data point number 2, data point number 3, and data point number 4. In case that relative purchasing power parity holds perfectly, like the regression line will have a slope equal to 1, so a positive slope of 1, and the regression line will also go through the origin, so that the intercept is equal to 0. So based on this stylized example, we are able to derive our hypotheses. Let's write down the regression equation. So we have the relative change in the exchange rate on the left-hand side, an intercept alpha, a slope beta, and then the inflation differential here. And then we have the error term in the end. We have two pairs of hypotheses. So intercept is equal to 0. This is a null hypothesis. And intercept is unequal to 0. This is the alternative hypothesis. With respect to the slope, the null hypothesis is beta is equal to 1. And with respect to the alternative hypothesis, it is a case that beta is unequal to 1. Like when we write down the hypotheses in this way, we know that we want to perform like a two-sided test. In my class, we always want to test on a 95% confidence level, and as we are also assuming that we have enough observations so that the normal distribution is the appropriate choice. So therefore, like the critical t-value will be equal to 2. In case that you want to be precise, it's 1.96, but like a critical t-value of 2, that's really sufficient in my course. So when you run a regression for the time period 1973 to 1995, so where before there was a Bretton Woods system in place, so the exchange rate was a fixed exchange rate, and afterwards Italy and Germany are preparing for the euro, or the euro was in place so that the exchange rate is fixed. So I really want to cover like an era where we have floating exchange rates in place. When we run a regression, this is like the regression output of Excel. Of course, to some extent, we have to be careful with this t-statistic here, because this t-statistic will be misleading. Excel is always using like the default option that we want to test that the coefficient is equal to 0, but this is wrong when it comes to the slope, because we want to test relative purchasing power parity, and there like we want to know whether the coefficient is equal to 1 and not whether like the slope is equal to 0. So we have to be careful like with this t-statistic here. Therefore, like let's interpret the confidence interval first. That's easier. Like the claimed value of 0 is not included in this confidence interval. Therefore, like we are rejecting the null hypothesis that alpha is equal to 0 and alpha is unequal to 0. What about beta? The claimed value beta is equal to 1 is not included in the 95% confidence interval, so we are rejecting also the null hypothesis that beta is equal to 1. Let's check once more. The lower bound of the 95% confidence interval is negative. The upper bound is smaller than 1. Hence, like the 1 is not included in the confidence interval, and we have to reject the null hypothesis. Beta is not equal to 1. So the empirical evidence is not in line with relative purchasing power parity. Beta is estimated to be a positive 0.4, but it should be equal to a positive 1. So both coefficients are significantly different from the claimed values on a 95% confidence level, so relative purchasing power parity does not hold. When it comes to the t-values, the estimated t-value is computed as follows, like estimated coefficient minus claimed value divided by standard error. We claimed in the hypothesis that alpha should be equal to 0, and therefore we are coming up with the following test statistic. So 4.91, the estimated coefficient minus the claimed value of 0 divided by the standard error. And we get the value of 2.32. So this is like given here in equation 3. What do we have to do with this value, 2.32? like this graph helps a lot. We have to find the value of 2.32 on the horizontal axis. It's located here. And therefore, like this border of 2 is crossed. And therefore, the conclusion has to be like we have to reject the null hypothesis. With respect to beta, we have to be careful because this t-statistic is misleading. Like Excel is computing the t-statistic in the following way: 0.42 minus 0 divided by 0.24. And then the result is 1.76. But this is misleading. It's the wrong t-statistic. Like we have to use this formula here, 0.417 minus 1 divided by the standard error. And therefore, like we get a minus 2.46 here. We want to test whether beta is equal to 1. And we don't want to test whether beta is equal to 0. So this is like the right estimated t-value. This picture helps a lot. So we are also in this area here. And we have to reject the null hypothesis that beta is equal to 1. So like this is the first part of the lecture. And now I directly want to go to Excel and perform this regression analysis. So maybe in a first step, we can have a look at the inflation rates and the inflation differential. So I'm plotting like the data set by using two line diagrams here. The blue line, that's the inflation rate in Italy. The orange line, that's the inflation rate in Germany. And hence you can see here that there is like a pronounced inflation differential, especially like in the 1970s and in the 1980s. Like the inflation rate in Italy is always larger than the inflation rate in Germany. And in case that relative purchasing power parity holds, like it should be the case that a depreciation of the Italian lira takes place. And when we like plot the data, this is indeed the case. So like in this line diagram, we have plotted the exchange rate, like the price of 1 German mark measured in Italian lira. And in the beginning, the price of 1 German mark was at the level of 200 Italian lira. And this increased like tremendously during the 1970s and 1980s. And in the end, the price of 1 German mark is at the level of like 1,140 Italian lira. So we can see here a depreciation of the Italian lira, and that's in line with relative purchasing power parity. So like it is the case that Italy has problems with the internal price stability, and Italy also has problems with the external price stability. But let's check whether relative purchasing power parity holds. Like in a first step, we have to compute like the inflation differential. So like this one minus that one, this is the inflation differential. And the relative change in the exchange rate can be computed as follows. Like I'm using this formula here, like the natural log. So natural log of this one, natural log of like this number, minus the natural log of this number here. I close the brackets, and then I multiply through like by 100. And now I think I made a mistake here. So once more. So like inflation differential, it is like C7 minus D7. This is the inflation differential in 1973. So please forget what I was talking about in the last 2 minutes. So inflation differential, that's C7 minus D7. And now the relative change in the exchange rate, it's like the natural log of this one minus the natural log of that one, and then multiplied through by 100. And now I can copy the information down. So the big white cross will become a small black cross. Double click on that. And we have the inflation differential like over time. And then also here, big white cross becomes a small black cross in the right lower part. Double click. And we have the information. Now I'm marking all my data. I'm going to insert and then XY scatter diagram. I take the first one and then I'm clicking on one cell, double click on the graph, fast layout, layout number 9, like third row, third column, layout number 9. And then I get here like the information from the regression line. So a regression line is inserted in my diagram. You can format this a little bit more, like put some labels on the horizontal axis, like inflation differential. And you can also make this one in red ink and a little bit larger. But this is our like regression equation, which we have seen before in our presentation. So here you can see the coefficients. They are in line with what we computed here. Now, of course, we also want to get the complete regression output with the estimated standard errors and the confidence intervals. So we have to go to Daten. And in case that you don't find, like here, the regression tools, we have to install it. Hopefully it works. We have to go to more, like options. And then we have to go to add-ins. And we have to go to solver and analyzes functions. So this should be installed now. Yes. Now, when you go to like the menu point data, Daten, you find one tool, Datenanalyse, data analysis, and there in the lower part, you can find the regression tool. So Y variable, I've marked it here. That's the relative change in the exchange rate. I'm including row number 6. Then X variable, that's the inflation differential. I'm also including row number 6 here. I make a check at labels like Beschriftung because I included row number 6. And that's it. I'm going to the OK button, pressing the OK button. And then I'll see here my regression output. You have seen this regression output before. So I want to format it a little bit so that you can see that this is the same stuff as we have seen before, like this kind of stuff. We don't want to see the R squared was also included in the graph. So let's cross-check. Like here, we can see the graph. The R squared is 0.1285. And also, when we have this regression output here, like the R squared should be the same. The coefficients should also be 100% the same, else like there is a mistake. Like, let's format it in this way so that you can see that this is like 100% the same as here. So thank you so much for the first part, and I'll press the stop button now, and we'll start again.